Yes, welcome back from force. Today we are going to continue with the experiment that we did last time, dealing with the rates of reaction. And you remember we collected some data on this. We did an experiment and recorded the data. We got the mass. Then we also recorded the loss in mass. We calculated the loss in mass. Like here, the loss in mass is 0 because there's no change. Then when you move here, you subtract the original minus the final. You get that. You come to after 60 minutes. It is original minus the final. You record that. After 90 minutes, 90 seconds, it is that minus the final. So that is the values that we recorded. And after recording those values, then we were told to plot the graph of loss in mass against time in seconds. So we were supposed to have a graph. And with that graph, we were supposed to have loss mass, and loss in mass is in seconds. Loss in mass is in grams over time against time in seconds. This is what we were supposed to plot. So if you will plot that graph, like in this case, I have we have our loss in mass in grams, and on this side we have time in seconds. So if you plot the graph, we'll have 0, 0.1, 0.2, 0.3, 0.4, that way. Then on this side we'll have 0, 25, up to that. So the graph will appear in the shape that I have here. That is the graph of loss in mass against time. Now, so in this graph, remember it has 3 marks. There's mark for labeling, and when labeling you must write what is here, loss in mass and the units. Down here you must also write the time and the units. Then your scale must be correct, must cover more than a half of the page, and you can see my graph. If you take from here up to here, my graph has covered more than a half. We don't look for this, what you have drawn here. We check the curve, the area covered by this curve. It has covered from this point to that point. That is more than 3, more than a half. And again, plotting should be right. Those points must be accurately plotted, and the curve must be smooth. Then you get your 3 marks. Curve of loss in mass against time. I told you to draw yours. It's very important to practice drawing graphs. Then the second question, we are told explain the shape of each curve. Okay, explain the shape of the curve. We only have one curve so far. We've done the second experiment. So we have the curve, and we are told to explain the curve. Now, if you look at this curve, the rate of reaction, there is loss in mass at the beginning, up to 150 seconds. At 150 seconds, the mass remains constant. So, from there we can say that the rate of the reaction is higher at the beginning. So at the beginning, the rate of the reaction is high. Is high. but levels off at 150 seconds. So at 150 seconds, the rate of the reaction levels out, meaning the reaction remains constant. And why does the reaction remain constant? Because we have the limiting reagent. The limiting reagent here is the one which is not in excess. So we have this thing moving this way, but at 150, starting from 150 seconds, it remains the same. So the rate of reaction increases up to 150 seconds, where it remains constant. Now, if you take calcium carbonate, you add to HCl, you get calcium chloride plus water plus CO2. This one was in solid form, marble chips, aqueous, liquid gas. So the loss in mass, because if you look at our table, you will realize that as the time proceeds, as the experiment was going on, the mass was going down from 110.9, 110.6, 110.4, 110.2, 110.17, 110.10. So there was a decrease in mass. Why was there a decrease in mass? The decrease in mass was due to the production of carbon dioxide. So this carbon dioxide is coming from calcium carbonate. And this carbon dioxide is escaping. And this is a gas with weight, that's mass. So as the CO2 escapes, the mass which is equivalent to the CO2 form must be lost. So the loss in mass was due to the reaction taking place. As long as there is a reaction taking place, CO2 will be formed and there will be a loss in mass up to the point where the reaction becomes complete. Now the question is, when does the reaction become complete? The reaction becomes complete when all the hydrochloric acid has been used up. So we had excess calcium carbonate, but limited. Limited means not in excess hydrochloric acid. So at this point here, the hydrochloric acid had been used completely, and therefore there was no reaction at 150 seconds, and that is why the graph remains constant, meaning there was no change in mass, there was no loss in mass. And if you look at the table, come back to the table, you'll realize that the mass remained the same, 110 after 150 seconds and 110 after 180 seconds. There was no change in mass, there was no loss in mass. So that is the reason. So we say that the rate of the reaction is higher at the beginning, but levels off at 150 seconds, because at 150 seconds all the hydrochloric acid had been used up. Therefore, the reaction was complete. The reaction was complete. Then there is this one here where you are asked, what does the reading? Okay, let me correct that. What does the reading 110? It should be 110.00 represent. So for us, we should be talking about this reading. what does the reading 110.9 represent? What does the reading 110.9 represent? So the reading 110.9 represent the original mass. What is that original mass? The original mass is the original mass of the calcium carbonate plus the hydrochloric acid plus the conical flask. Because we had in our experiment, we had a conical flask and an electronic balance. So the original mass was 110.90. This 110.90 was the mass, the original mass of the conical flask plus its contents. Of the conical flask plus its content. So the mass of the conical flask and its contents. Then, what was the loss in mass in each experiment after 75 seconds? Loss in mass after 75 seconds. So this one we are going to move back to the graph, and moving back to the graph, you come to the graph, just zoom, you come to the graph and then you check 75 seconds, which is here. After checking 75 seconds, you draw a dotted line to cut the curve. Then you also extend the dotted line to cut the y-axis. Then you read. From here, it is 0.56. So at 75 seconds, what we have is 0.56 grams. So the loss in mass at 75 seconds from the graph is 0.56 grams. Let us stop a bit and then meet in the second segment of our lesson.